All right, so in this video, we're going to take a look at some different identities. And so to get started, all of the other identities that we'll study in the course actually, and I'll do some labeling here of some points, cosine of some that we're going to derive. The first part, this one's going to be a little worse than some of the others, but here we'll call the angle alpha, which means the point on the unit circle would be cosine alpha, sine alpha. I'll go ahead now and construct another angle, maybe one out this way, where the angle between the blue and the green, that is what we're going to call beta. So that's angle beta, which means, again, on the unit circle now, the point would be cosine of alpha plus beta sine of alpha plus beta. Now, going the other direction, similarly, this angle will be a negative beta, moving in the clockwise direction, which means that the point here is cosine negative beta sine negative beta. Now that point can actually be cleaned up a little bit because of the even-odd identities. So since cosine is even, that's the same thing as cosine of beta, and since sine is odd, that's going to be negative sine of beta. Now, using some basic geometry here, I'm going to take the line segment between this point and this point, and notice that the angle here opposite the red segment, the angle here, this is alpha plus beta. And similarly, if I connect these two line segments, the angle opposite the red segment would be an alpha plus beta here as well. So by geometry, since this angle and this angle are the same, these two red segments also have to be the same. And that's what I'm going to use to get this thing started. Using our distance formula, we're going to have the square root of cosine alpha plus beta minus 1 squared plus sine of alpha plus beta minus 0 squared. So that's just the distance formula for between this point and this point here. Now I'm going to go ahead and set that equal to the distance formula between this point and this point. So that's going to be big square root. We've got cosine of alpha minus cosine of beta squared plus sine of alpha minus a minus sine of beta, so plus sine of beta squared, and that's again all square rooted. Now, if we come through and we clean this up, which is what we're going to do, a lot of it should fall apart pretty nicely. So I'll come through and I'll square both sides. On the left, we'll have cosine squared alpha plus beta minus 2 cosine alpha plus beta plus 1 plus sine squared alpha plus beta. On the right-hand side, I'll have two binomials to expand here. I'll have cosine squared alpha minus 2 cosine alpha cosine beta plus cosine squared beta. And then I'll come down here, I guess, and write that, plus sine squared alpha plus 2 sine alpha sine beta plus sine squared beta. So again, just a lot of foiling there. Now, fortunately, a lot of this cleans up. For example, cosine squared and sine squared of alpha plus beta equal 1, plus another one gives us a 2 minus 2 cosine alpha plus beta. And then on the right-hand side, cosine squared alpha, sine squared alpha is 1. Cosine squared beta, sine squared beta is another 1. So this is going to give us a 2 minus 2 cosine alpha cosine beta plus 2 sine alpha sine beta. So if we go ahead and now subtract 2 from both sides, you can see how those go away. I'm also now going to multiply everything by a -1/2, or divide everything by a -2, which would go ahead and do away with the constant of 2 throughout. So that's going to give us cosine alpha plus beta equals cosine alpha cosine beta minus sine alpha sine beta. And that would be the identity for cosine of a sum. So cosine of a sum, alpha plus beta. Cosine of a sum is cosine alpha cosine beta minus sine alpha sine beta. Now that one was the most difficult to derive, but because we've come up with it, now we can use it for other things. The next identity would be cosine of a difference. So cosine of alpha minus beta, which we're going to go ahead and view now as cosine alpha plus a negative beta. So I've rewritten cosine of a difference as cosine of a sum. So we've got cosine alpha cosine negative beta minus sine alpha sine of negative beta. So just again using the identity we came up with just a moment ago. Cosine is even, so the negative gets absorbed, or we don't pay attention to it. And then sine is odd, so the negative will have to come out in front. So for cosine of alpha minus beta, we have the identity now cosine alpha cosine beta plus sine alpha sine beta. So a pretty easy one to come up with if we already have cosine of a sum. All right, so now we'll go ahead and take a look at the cofunction identities. Now, I've got a right triangle here, similar to what you see in the notes, with an angle theta marked. We know that there are 180 degrees in a triangle, so the missing angle up here would have to be the 90 minus theta. But I'm going to go ahead and write it as pi over 2 minus theta to keep things in radians. Now, labeling things like we normally do, I might call this X, I might call this Y, and then I'll call that R. And so now we're just looking to make a couple observations. The first observation would be sine of theta. Sine of theta, based upon how we're set up, would be the Y over R. Now, if I take a look at cosine of pi over 2 minus theta, so now I'm looking at this angle right here. And so cosine of this angle would actually be the Y over the R. So it looks like sine of theta is the same thing as cosine of pi over 2 minus theta. So that's one of the identities, the cofunction identities. So sine of theta, cosine of pi over 2 minus theta. Now you'll find that because of the names, the cofunctions, they're all going to do that. Sine and cosine, tangent and cotangent, secant and cosecant will all do the same thing. So maybe I'll show one more on here, and then I'll leave the rest to you guys. So let's say we want tangent of theta. Well, we know tangent of theta is going to be the Y over the X, and then cotangent of pi over 2 minus theta. Again, now I'm looking right here, and cotangent would be the, for this angle right here, would be the Y over the X again. So now we can say that tangent of theta equals cotangent of pi over 2 minus theta. Again, another example of a cofunction identity. And the rest you can also find in your book, but I have a feeling if you take just a moment and look at these and represent these trig functions from both perspective of theta and pi over 2 minus theta, you'll be able to come up with the rest on your own as well.